Let's do an example from start to finish for solving a system of first-order differential equations. What we'll do is we'll first find the eigenvalues, and we do that by taking the determinant of a minus ri and setting it equal to 0. We then solve for r. We should get two values. We then find the corresponding eigenvector for each eigenvalue, and finally we build the solution. Once we have the solution, we'll use our initial conditions in order to find the C1 and C2. So here's my problem. X prime equals the matrix 1, 3, 3, 1 times x. And my initial condition is x0 equals the vector 3, 1. First, we find the eigenvalues. So when I take the determinant of a minus ri and set that equal to 0, I get the following matrix. When I take the determinant, this is what I get, and after I multiply everything out and combine like terms, I get this, and finally I'll factor. So this means I have two distinct real eigenvalues. R1 is equal to 4 and R2 is equal to negative 2. Let's go ahead and find now the corresponding eigenvectors. We're going to be using these formulas. So for the first eigenvalue, R1 equals 4. This is what my matrix turns out to be. Again, I'm only going to use one row because both of the rows are linearly dependent. And I get that u1 and u2 are equal to each other. So the eigenvector I'm going to use is simply 1, 1. Notice I could have used 2, 2, or negative 3.4, negative 3.4. I like 1, 1. And now the same thing for my second eigenvalue. This is what my matrix ends up looking like, and when I multiply this out, I get the relationship that u1 is equal to negative u2, or negative 1, 1. Remember, we always switch our coefficients. The next step is to build our solution. When I have two distinct real solutions, this is what my general solution will look like. And after I plug in my values for r and u1, u2, this is what my solution is. Our last step now is to find the C1 and C2 given our initial condition. I know that my initial condition is x0 equals 3, 1, and so this is what I end up with. Again, I'm plugging t equals 0, and I'm plugging in 3, 1 for my value of x at that time t. I go ahead and use my rules for multiplying matrices by scalars, and now I'm going to go ahead and add my matrices. I now have two equations with two unknowns. Now I'll go ahead and solve this by elimination. So I find that C1 is equal to 2 and C2 is equal to 1. Let's put this all together now. And this is my final answer. You can write this in either one of these two forms, either as two separate vectors or combined into one single vector.